Let's use the continuity definition to evaluate the limit as x approaches 2 of this function, parenthesis x cubed minus 3x plus 1, close parenthesis, to the negative 3 power. Okay, we know that here we have the limit as x approaches a of f of x is equal to the limit of parenthesis x cubed minus 3x plus 1 to the negative 3 power. But let's simplify that. It's the limit as x approaches 2 of 1 over x cubed minus 3x plus 1 entire quantity raised to the positive 3 power. Now we know something about rational functions. Rational functions are continuous on their domains. So we know this is a continuous function if we could be sure that a equals 2 is in the domain. Is a equal to in the domain of this f? Well, let's find out. The question is, does the evaluation of the denominator x cubed plus 3x minus plus 1 to the third power, is that equal to 0 when x is equal to 2? I don't know. We don't want it to be, but let's find out. 2 to the third power plus 3 times 2 plus 1 cubed gives us 8 minus 6 plus 1 cubed, 2 plus 1 cubed, 3 cubed, which is 27. That's definitely not 0. Great. Thus, since x equals 2 does not give us a 0 denominator, we can be sure that this value a equals 2 is an element in the domain of our function f. Therefore, since we have a rational function and a is in the domain, f of x is continuous at a equals 2. Thus, by the definition of continuity, we know that if we evaluate the function at 2, it's the same as taking the limit as x approaches 2. That's the definition of continuity. So let's answer the question. Let's use continuity to evaluate this function. Thus, the limit as x approaches 2 of x cubed minus 3x plus 1 parenthesis to the negative 3 power is f of 2. Okay, well, what is f of 2? It's just 1 over 2 cubed minus 3 times 2 plus 1 cubed, which is 1 over 8 minus 6 plus 1 parenthesis cubed, which is 1 over 3 cubed, which is 1 over 27. So we used the definition of continuity to take a shortcut in evaluating the limit of this function.